The first explanation of the lateral deflection of a spinning object was credited by Lord Rayleigh to work done by the German physicist Gustav Magnus in 1852. Magnus had actually been trying to determine why spinning shells and bullets deflect to one side, but his explanation applies equally well to balls. Indeed, the fundamental mechanism of a curving ball in a soccer ball is almost the same as in other sports, such as baseball, golf, cricket, and tennis. Soccer factoid. The fastest recorded kick is 70 miles per hour. Consider a ball that is spinning about an axis perpendicular to the flow of air across it. The air travels faster relative to the center of the ball, where the periphery of the ball is moving in the same direction as the airflow. This reduces the pressure, according to Bernoulli's principle. The opposite effect happens on the other side of the ball, where the air travels slower relative to the center of the ball. There is therefore an imbalance in these forces, and the ball deflects, or the ball follows its nose. This lateral deflection of a ball in flight is generally known as the Magnus effect. The forces on a spinning ball that is flying through the air are generally divided into two types: a lift force and a drag force. The lift force is the upwards or sidewards force that is responsible for the Magnus effect. The drag force acts in the opposite direction to the path of the ball. Let us calculate the forces at work in a well-taken free kick, assuming that the velocity of the ball is 25 to 30 milliseconds minus 1, about 70 miles an hour, and that the spin is about 8 to 10 revolutions per second. Then the lift force turns out to be about 3.5 N. The regulations state that a soccer ball must have a mass of 410 to 450 grams, which means that it accelerates by about 8 milliseconds minus 2. Since the ball would be in flight for 1 second over its 30-meter trajectory, the lift force could make the ball deviate by as much as 4 meters from its normal straight-line course, enough to trouble